Thank you, Rida, and hi everyone. I'm very happy to present my field of research in front of such young audience and enthusiastic. I hope it will be for you of some help in your career choice. So why do a PhD in stochastic games? Actually, I think for me it was kind of love at first sight, so I didn't really think much about it. But I will try to find some rational reasons to do it. And I will not go into heavy formalism because there are many different types of models. So let me just give a basic structure. What can we call stochastic games? Well, stochastic games describe repeated interactions between players with the particularity that the environment is dynamic. So the rules of the games may change from one stage to the other. And more precisely, at each time period, each player picks some actions, and as a result, he will receive a payoff that depends on all the action stage. And this payoff also depends on a variable called state. And as a result of the actions, the states change and will be different in the next stage. And there is also a stochastic aspect. So for example, just to give you one class of such games, so resource extraction games, you have players that aim at extracting some resource. So it could be oil, or in this picture, it could be fish. So these fishermen, each day, they take a decision how long they will fish, how much fish they will take. And as a result, this will affect the number of fishes in the river. And so as the next time period, there will be maybe less fish if they fish too hard. Sorry, maybe I have a huge voice. And so also this state can be affected by stochastic processes. For instance, if the weather is bad, it will also affect the distribution of fish. Yeah, so actually, if you think about it, there are many different types of stochastic games, many different examples. Actually, one famous game theorist once said that everything is a stochastic game, which is a kind of a bold statement. But at least here are a few pictures that show the diversity of stochastic games. So patrouilling games, where you have one player that try to defend a facility, like a harbor, and one player that is an attacker and wants to attack the facility. And here the state of nature will be like the position of the players. Also investment is a good example of stochastic games, so where you have players that decide where they put their money, and this affects the prices. And of course it has a dynamic feature, because if everyone buys the same stock, it will put the price higher in the next time period. Research can also be viewed as a stochastic games, because you have to decide which time and how much money you invest in which topic, and of course the more you invest, the more later on you will have returns of what you do. And also football is also a stochastic games, where the state can be the position of the ball, the health of the players, the goals that have been scored so far. So, in fact, stochastic games are like kind of everywhere. And this also means, from a theoretical point of view, that there are many different types of theoretical models according to what you assume and the information of players. So, for instance, in football, you know where is the ball, but you may not be aware fully of the health of the players, for instance. Also, with regard to the state evolution, your state maybe will have some kind of ergodic structure, meaning that it will visit any possible situations in some finite number of times. Or it can be also, maybe I say it's stochastic, but maybe you can assume that in fact there is no randomness, so it's deterministic. You can also, from a topological point of view, think about what are which structure have the sets describing your game. So the action sets, you may assume that they are finite, but you can also assume that they are compact or even more general structure. The number of players is also subject to variation. You can have 0 player, 1 player, 2 players. Actually, 0 player may seem a bit strange, but if you think about it, what is a game, a dynamic game without a player is just a dynamical system. So you can call it a Markov chain. And Markov chain is an important field of mathematics. One player is what we call Markov decision processes. We have already seen before examples of the zero-sum game, so where we have 2 adversary players, and you can go also to infinite player case. Time can be discrete. I mean, in the example so far, I was saying at each time period, but you can also imagine continuous time model. It's also possible. And in terms of objective, what do the players want to do? Well, it's up to your application and up to which model you are considering. You may consider like they want to optimize the average payoff, or maybe they want to optimize the payoff at the very last stage of the game. Maybe, like often in economics, there is a discount factor. Maybe they prefer to have good payoff today rather than tomorrow, and so on and so forth. And all these different models yield to different application and different questions. So stochastic games, as game theory in general, is a very interdisciplinary field and lies at the intersection of computer science, economics, and mathematics. I just give below just a few examples of things you can do related to each field. For example, from computer science perspective, you can look at what is the cost of computing the solution of the games, how players can learn how to play well. Of course, this question you can already ask it in a static setting, but the fact that you are considering dynamic setting with a game that evolves around the time period bring new questions and new challenges. From economics, I think you can also ask Johannes Horner for very good stories of applications, but there are many possible applications. Like I talked about resource extraction games, also competition, security, cyber security, like patching games. Those are many different applications. I'm a mathematician, so I'm obviously biased toward mathematics, and I think stochastic game is a good, very good, particular good field for mathematicians. When, from a mathematics point of view, when you have a dynamic game or stochastic game, you want first to see if there exists some solution to your game, so existence of equilibrium. And in doing that, you will explore many different types of mathematics that I will detail in the next slide. You will have also interesting question about what happens when the game is very long. So limit time behavior. Can we talk about long-term optimal strategy or long-term equilibrium payoff? And also the model structure is topologically very interesting. Which assumptions you put on the action sets and the transition of the game on everything leads to many interesting problems. So let me just talk a bit more about the mathematical aspect. So when you want to prove existence of equilibrium, you will go to operator theory, fixed points theorems. You will also work on convex analysis. When you are notably when you are talking about random strategy, for instance, strategies that rely on randomness, and also partial differential equation. If your game has continuous time, then you will often characterize the equilibrium in terms of a partial differential equation. So, with respect to limit behaviors, it will bring you to the world of martingales, of Markov chains, also of ergodic systems, ergodic theory. With respect to model structure, of course, your topology, like which topological assumption you put on all the sets. When you want to define strategy in an infinite world, you will also go to measure theory. And also, when you want to model how information circulates along the game, how players acquire information about the unknown variables, then you will also go to information theory. So there is a very huge spectrum in the stochastic game theory, and it's quite remarkable that just one model can have so many different things, theoretical things at hand when you study it. I would like also to mention the fact that so you have stochastic games. This motivates new mathematical questions. Okay, you use mathematical tools to solve these questions. Okay, like probability theory, analysis. But it also works the other way around. Stochastic games have been used to solve mathematical problems outside game theory. So, for instance, there are several papers that prove existence of a solution of partial differential equation using the stochastic game language. And same thing for discrete equations, and also the limit time behavior of partial differential equation has also been studied through stochastic games. One of the reasons is that there are partial differential equations, remarkably, that appear both to describe games, but also to describe physical phenomenon. So two completely distinct things, games and physics, can interact through the same equations. And this is the reason why you can somehow reverse things and use game theory language to study mathematics outside game theory. So this was a very general description. I just want to give you one example of questions that I'm working on, and also to tell you that, in fact, one of the good things about stochastic game is that there are questions that you can state in 3 lines, but that are still interesting to work on, and that I still I'm not able to solve. So you have a game where you imagine an infinite grid, and you draw a coin at each vertex, 1/2, 1/2, and if it's heads, you put 1, and otherwise you put a 0. And then, very simple game, you have 2 players. You put a token or some object in some point of your grid, and then player 1 chooses to move the object left or right, and then player 2 chooses to move it top or bottom, and so on and so forth, and you repeat these interactions. And then player 1, he likes the ones, so he wants to maximize the number of ones that the object go through. And also one important point is that all the players know the realization of the 0 and 1. So they know the infinite grids, they know where are the payoffs, and they just play this way. Can someone come up with a smart program to compute the outcome of this game in a reasonable number of times? And can someone tell about can someone approximate the payoff solution of this game? These are open questions. If you have any idea, I would be happy to listen to them. Conclusion, so why do a PhD in stochastic games? So what I think is remarkable is that the model structure is rather simple. This was the first slide. Okay, so it's just an environment where you have players that take decision, and the rules of the game change from one stage to the other according to this decision. But it's very, very broad in terms of technique and in terms of fields. So for you, it will be an opportunity to develop many different types of skills in computer science, in mathematics, in economics, and it will grant you a very wide range of choices for your career. And also, this is one of the topics in game theory that is very well recognized in mathematics, in the sense that there are many stochastic games papers that are published in top journals that are not game theoretic journals. So they are mathematical journals, and so this means that it has a lot of recognition from mathematicians. And also, I think it's okay. It's a personal point of view, but I think it's very elegant in the sense that, for instance, the questions that I just asked before is rather simple, but still it connects to interesting phenomena in probability theory and in games. And in general, I think it's good to do a PhD in game theory, not only in stochastic games. I think it's also good to do a PhD in general, here are a few motivations of why you can do why you should do also a PhD. I put a few references, and yeah, and thank you very much.
Thank you, Bruno. So the 5 people that just talked, all of them will be in the associated with the PhD program, in the sense that they are going to be in the second trimester teaching specialization courses. Hopefully they will be also involved in PhD supervision with us here. And so that's, but they will not be the only one in this teaching. So there are other people that will be also coming and teaching. And so that was a panorama, I hope, useful of the Game Theory Center, the PhD program in this Game Theory Center. Hopefully you will have this. It will give you an idea if you want or not to do a PhD. If you want to do it, then just apply when applications are open. We are going to look at all applications seriously, and I will do my best to have the maximum of you inside this program. Okay, and that's all I wanted to say. And I would like to thank all the participants, students, professors, staff that helped me doing this. And now it's the new life of Game Theory Center started today. Thank you.